what's the practical application? And for that, I would recommend that if you want to Google something, what's the application for measuring density? You probably pull up more information than you need. So those 4 sections in your result and discussion basically summarize your result and talk about the error sources of error, and summarize what you learned, and then what is the practical application. Those are the things that we want you to focus on when you do result and discussion. Now, in your lab manual there, in each section, you see the last page of each experiment pretty much, and you see a list of things that you need to include in there. And there's always a section that says result and discussion, what you need to include in there. So as long as you cover those 4 areas, and I would be okay. And sometimes, the requirement in the lab manual, in the current version of the lab manual, asks you to draw diagrams and put down safety precautions. Yeah, well, you can put that information in there, but if you don't, I'm okay with it. So that's something that when I was grading your lab report, basically, and some of you completely missed that part, result and discussion, just present in the data sheets. Well, that's not enough. And if we have worksheets and questions on the worksheets that you need to turn them in. But the result and discussion actually is the most important part of your report, of your lab report. So that's always something that we do want you to pay attention to. Okay. And I know I've been talking to many of you regarding the lab activities there, and some of the descriptions there, and it's not as clear as I want it to be, to say the least. And so, in a sense, I can feel your pain when you go through a course with this kind of intensity and this kind of pace. We want to give you as clear as possible instructions, but unfortunately, some of the instructions in the lab manual is kind of confusing. And also, the question that you had on the previous lab quiz, there was a question giving you the mass of the anhydrous salt, give you the mass of the hydrate salt. The question asks you to calculate how many moles of water in the formula, but the wording there, after I read the question, the wording in there made me feel that we're only trying to ask you to calculate the total number of moles of water based on the information given there. So most of the class, when I was grading the quiz there, most of the class did not come up with the formula for CuSO4 based on that information, which is, I think, the intention for that question there. So I gave you full credit as long as you do the calculation correctly for the number of moles of water. So basically, mass of the hydrate versus minus the mass of the anhydrous, and that's the mass of water. And then that mass divided by 18.02, you get the number of moles of water. You can also determine the number of moles of the anhydrous salt there. So it's not your fault. And then when I was first looking at the equation there, that question there, I got the same feeling that we're supposed to calculate the number of moles of water. And then when I read a little bit more into the question there, I realized, well, the intention really is you need to figure out the formula for this compound. And when we don't have a very clear instruction in a given question there, and I will give you the benefit of the doubt, and you know how to do it. The question didn't ask you clearly to do that. So if you didn't do it, some of you did and come up with the formula. Most of you didn't, and that's okay. When you get your lab quiz, when you get a chance to see your lab quiz today, you will see that as long as you answer that question correctly with the number of moles of water, you get the credit for that part of the for that part of the quiz. Okay. So we've been talking about chemical reactions all along since the beginning, and we were focusing on the matter side of the chemical reaction. So today we're going to switch gears a little bit, and we're going to take a look at the energy aspect of the chemical reaction. What happens in terms of the energy accompanying the chemical reaction there. So this is the part where we call thermochemistry. Okay? Thermochemistry studies the energy aspect of chemical reactions or physical changes there. And there's always an energy requirement whenever you have something happen. Chemical reaction, physical change, and there's always an energy requirement. So we want you to make sure you take the time and read the textbook there. Now this is going to be, chapter 6 is going to be part of exam number 3. Okay, so the upcoming exam next Tuesday will cover chapter 3, chapter 4, and chapter 5. And those 3 chapters, I must tell you, those 3 chapters are calculation intensive. So there is a review document for that, exam number 2 on Canvas. If you click on exam number 2, and the page opens up and you see that document, there are 20 questions in there. And again, when you do those 20 questions there, give yourself only 40 minutes for those 20 questions. You need to be able to finish those 20 questions within 40 minutes. If you take more than 40 minutes, it's a good indication you won't have enough time for the second exam. Okay, so that's just the nature of those 3 chapters there, and there's a lot of calculations involved, there's definition involved, but majority of the questions involve some kind of calculation. Some are complicated, some are easy, but you should expect to have a lot of calculations involved in there. Now this particular chapter is going to be in the 3rd exam, chapters 6, 7, and 8. Those are the 3 chapters that will be covered on the 3rd exam, which is the Tuesday after next. And I believe the current date is the 23rd of June. And there is a possibility we may need to push it back to 25th of June. So we'll give you 1 or 2 extra days to study for it. Currently, at this point, we're going to try to stick with the schedule, because I mean, by June 29th, that's the last day of class, and we have to finish everything. So we can't just push everything back. And there is a deadline, there's an end date there. Okay, so for thermochemistry, this part, and again, homework still, a question is assigned in the homework still belongs to homework number 2. And there are 4 learning objectives in this particular chapter. And the first thing when we look at thermochemistry, we want to be able to do certain things. How do we define energy? How do we define heat? What is the unit for measuring heat, measuring energy there? What are the specific terms that we use to describe a particular physical chemical process? What is an exothermic, endothermic reaction? What is work? How do you define a system? How do you define a surrounding? So that's our first learning objective there. And again, thermochemistry is the study of the energy change that accompany chemical reactions and physical processes. Okay. So prior to this point, we are looking at the matter side of the chemical reaction and physical processes there. Now we need to know how much energy does it require, or if a process requires energy in order to occur, how much energy does it require? Or if a process actually releases energy, how much energy does it release? Okay. So there's always a give and take of energy, and there's always an energy aspect associated with the chemical physical changes there. Using ice, water as an example, water freezes up. Okay, that's an exothermic reaction. Ice freezes up. That's an endothermic reaction there. That's an exothermic reaction. Actually releases energy there. Okay, so water can change from liquid to solid, and then can also change from liquid to gas, vapor. So in order to convert liquid water into gaseous water, you have to supply energy. So that's an endothermic process. And the term that we use, that in order for the process to happen, you have to supply energy to the system. Okay, and so that's an endothermic process. Now, if liquid water is freezing up into ice, energy is being released. So that's an exothermic process. And there's